Good afternoon. So, welcome to the third day of the DA Iconic Week. Today, basically, we have two talks. One is a technology talk, which will also showcase the technology developed by DAE for societal benefit. It's an immense pleasure for us that we have today Dr. Kuber, who is both a scientific officer and head of the Enzyme and Microbial Technology section within the Nuclear Agriculture and Biotechnology division at BARC. Briefly, Dr. Kuber did his bachelor's and master's in zoology and life sciences respectively from Sambalpur University, and he joined the 39th batch of training school of BARC in 1995. Subsequently, he obtained his PhD in 2009 in biochemistry. He has also worked for a year in Cincinnati. He has several publications including in high impact journals over the years. In particular, he has received the DBT Crest Award in 2012. Today he will be basically talking about a technology which has been developed by the division, which is of societal benefit. So the title of the talk is Development of BARC-Hydrogel, Improving Water Economy in Plantation and Agriculture. He will in particular talk about this technology called BARC-Hydrogel, also known as Mridamrit. So it's a pleasure, sir, that you managed to come in this iconic week while you're basically visiting so many places showcasing the technology. We welcome you to please deliver this.
Good afternoon, everyone, and I'm privileged to have been given this opportunity to present the work that we have done at IMSC, and I'm thankful to Director IMSC, Professor Ravindran, Registrar, and of course Professor Samal for actually inviting us and inviting me to have come here and showcase our development, what we did as a DA program, and how it is reaching to the society, what way it can benefit. And this is indeed a great platform when we are celebrating Azadi Ka Amrit Mahotsav. Nothing better than celebrating the success as well as looking forward to how more you can contribute towards the upliftment of the progress of the society and actually addressing issues which are of very high concern, such as water. So, coming to the topic, it is development of BARC-Hydrogel, improving water economy in plantation and agriculture. When you say BARC-Hydrogel and water economy, I think looks quite far apart. Just a hydrogel, how it's going to address water economy, which is kind of unimaginable. It's a huge subject. As you say economy, of course we understand, but at the same time water economy, when we say, it is pretty much important to know where and how it is going to impact for the societal development in the days to come, how water can play a role. With that will be how hydrogel can play a role to address any issues that crops up because of the water, either misuse or non-availability, or whether it is basically scarce. So we will see what attempt we are making in that direction as a department who is supposed to serve in all respects. Coming to the mandate that we work on, and that is Atom for Food Security. It is basically Vision 5 in DA program, and we are related to development in agriculture and food preservation, which is going to ensure food security in terms of production, protection and preservation, to ensure that every person in the country gets sufficient or good quantity of food with good quality as well. Nutritious, sufficient amount of food should be available for each and every individual in this country for growth of the society. So this is very important, and we work towards this objective. So as part of the Nuclear Agriculture and Biotechnology division, we have several programs. We have got biocontrol and integrated pest management. We have got crop improvement in terms of nutrition and biotechnology. We have got crop improvement in terms of nutrition and recommendation breeding. And then you have got biosensors and bioregulators, as well as soil health and agro waste management, which is the overall program that we run through so as to contribute towards the agriculture, better health of agriculture and better produce, and therefore better human health. This is what we look at. Now What do we do by, how DAE starts with agriculture, let's say farming, is very unique, isn't it? I will say very interesting. So what we do is that, let's say if I go to previous slide, if I am doing, let's say, crop improvement through mutation, either through mutation using mutation and biotechnology together, or mutation through traditional recombination breeding, I have to say that what is existing today is what it looks like in front of me. I want a change that I would like to have. How do you make the change? If you just ask the plant, he is not going to change as per use, who is. It has to be changed genetically. Now, to change genetically, there are various ways people have done in the past, using chemical mutagens, many others, to change the character. Let's say there is, as you know, the famous Mendel's law, Mendel's experiment on flower color, the red and white, shape of the seed, color, pod, everything. So, like for example, if you want to change a character, a mutation or change in the hereditary element is very important, which should be permanent. Now, to induce that, you can use both chemical means as well as physicals. Now, in our case, it is radiation. Typically, we use gamma radiation, and this is the example that I would like to give here. Typically, this is the gamma chamber, wherein you put a sample here, and once sample is put, it is irradiated by the slot going down, or the chamber goes down in this shielded source, and therefore it gets exposed to certain amount of radiation as per the optimized value. And after that, you will see whatever you are seeing here in this, actually will have some mutations change would have been occurred inside, that you have to basically monitor. And after screening, then whatever is the desirable change, if you have seen any, then you carry forward. So if that happens to be that change, that can be carried forward for multiple generations, as long as, like, you will go and see almost 6 to 7 generations. M6 is basically the seed that you irradiated is this M1, and after that multiple times you keep growing, and then after 6th or 7th generation, which eventually takes something like 6 or 7 generations, in certain cases 7 years, because one crop cycle 1 year, if you say it is 6 to 7 years, so then you can generate a variety, and that actually is supposed to be released as a proper variety for whatever benefit it is giving. Let's say you wanted a rice, which is, as you know, rice is a big problem sometimes for people who are having diabetes. So you want to have a diabetic rice. That means glucose content should be less. So in that case, what you want? A rice to be developed which has got lot of fiber but less of soluble glucose. So that means the rice has to be grown not only for 6 generations but countrywide at many locations and in many conditions. And only then, if it is giving consistent result, it can be called as a valid seed, which can be then cleared through Government of India, Ministry of Agriculture, to certify it as a seed which can be used by the farmer. So likewise, we start making such products which are basically mutation obtained after mutation, and those are called as mutant varieties. So we have developed such varieties, such 55 crop varieties have been developed with BRC since its inception. And of that, you can see there are 16 groundnut, urad bean, that is urad dal that we use for the idli, that is 5, mustard is 7, linseed 1, sunflower 1, cowpea 2, mung bean 5, rice 7, jute 1, soybean 2, and pigeon pea 5. This is altogether different crops seed that have been produced by our department. So what does it do? Basically, why you want to address this problem? As you know, due to different climatic change that happens, the soil condition, water availability, everywhere the things are changing. In every state, the geoclimatic conditions are very different. So to suit to that particular environment, you need a certain variety which will grow only there. That is one. Other is you want a variety which grows all over or in many states. So like that. So you can have preference for either of them depending on your need. So if you look at this picture, you can see where all we have penetrated in terms of reaching to the society by giving new seeds to the farmers. So this is what is all about, how we are trying to ensure food security for the country using peaceful application of radiation in our program through mutation breeding. Now, since agriculture is our main mandate in which we are trying to ensure food security, as you know, genetically you can manipulate, you can get a good variety, but how do you manipulate the environment? How do you ensure that such a proper environment exists in that area, in that place where the crop is growing. And one of the important requirement, as you know, is the water, because crop cannot grow without the water. So what does water economy has to do with agriculture? If you look at this, you can appreciate that water consumption is 93% of the total fresh water that we consume. So that is the kind of quantity we are, or the proportion. Let's say share. We say we are very, we get clear meaning when we say share. 93% share for agriculture. So what are the others? Whatever water we drink, bath, use for washing, minuscule in that comparison. But we feel that if the one day water supply is not there in house, we really make a lot of hue and cry. What about the crop? Who will make the hue and cry for crop? Crop is no one to argue, no one to ask for help. You have to help. So therefore, to address this issue, which is genuinely very, very important, as you know, everything stopped when Corona happened, but agriculture never stopped. Produce never stopped reaching you. You always eat. You are healthy enough to counter the disease, even then sitting at home. There is nothing called as online agriculture. You cannot do agriculture at home without going to the field. Okay. So the basic is water is basic necessity. There cannot be any doubt that water is the thing that is minimum required for agriculture. So why? You would have known these days there are very, very nice term coming. You can have everything. There is alternative to energy also. Okay, coal, there is no coal, look for solar. There is no solar, look for nuclear. There is no water, whom to look for? What is the answer? Can you make water? None of us can. We are dependent on nature. True? What is to be done? Just save it. Use it to maximum, as efficient as it is possible. Only then you can achieve some water security and water economy can be improved. That is why it's very, very important. And what does the water does for the plant? Water controls the plant growth and development. How many ways you can try to see the effect can be realized? If you have optimum and efficient use of water, you can ensure improved plant growth and therefore crop yield. Same way, crop quality. You will see, you will pretty much realize end of the season when there is very hot period comes in May, buy the tomatoes in the market. What is the size? This big. Healthy season, winter, what is the size? Nice, fresh, juicy. Because temperature, water, condition. But these days we still get, because why? Good quality tomatoes you get, because either they are stored or they are produced in controlled growth chamber, hydroponics, where all environment are controlled. So you can grow them in an environmental controlled conditions. You can get the nice quality fruits or vegetables, even land. So basically you can improve the crop quality, reduce water wastage. Why it is to be looked into? Because whatever you reduce wastage means you maximize gain. Then saving water by reducing irrigation frequency. What you do when you go to the field, irrigate using whatever surface water you have, be it pond, lake, or even groundwater pumping. What happens? You have depleted the resource. Number one. Number two, that if you are using more and more water in the same field, even if the other field next to you available it is, you cannot grow the crop because it may not sustain for that period. So therefore, if you reduce the frequency of irrigation, let's say extend the period from 5-day irrigation to 15 or 20 days, then probably within the same period, the next backfill land can be used to improve the produce, right? So likewise, so therefore reduce the cost of crop production. Now when the water availability improves, more arable land are available, more produce can come out in the same season, same time, therefore the cost can be compensated. And the farmer also is benefited because in the same effort, in the same area, visiting the same place every day, he will almost get similar, a better output. So that is how we can look at. I mean, I hope this is visible to all. This is how we see. One is that, okay, we are using 93% water. How does it matter? Can we conceptualize? A tree grows, Let's say we take water every day. How much water do we take every day? Roughly, what is supposed to be taken? 3 liters. A healthy person should take minimum 3 liters. Likewise, a plant also needs certain amount of water every day. If you consider the whole life cycle of the plant, one crop, let's say 3 to 4 months, and you see what is the produce it gives. You don't eat the whole plant. You get the plant product which are edible. It could be leaf, root, stem, flower, or fruits, seeds, any of this. Now these are the very different produce that I have enlisted. As you can see here, if we look for example the rice, 1 kg equivalent to, let's say 1 liter in terms of kg. If you take mass intensity same, then 2497 liter of water is consumed by the rice crop. So a rice plant which is consuming almost 2500 times of water is only giving you how much rice? 1 kilo. You finish in one day in your family. Just imagine the burden. Are you getting me? So this is the kind of burden we are giving in terms of water usage in the agriculture. There are many others which are different products. I am not going to emphasize more on that. So therefore, idea is to save, to improve the economy. Now how do you know that okay, this soil is having good enough water to sustain the growth of the plant? That soil varies from different part of, state to state, region to region, and from even within the state, many places. You will see they are not same, right? You get different types of water and soil. So soil moisture will depend on the texture of the soil, composition of the soil, and as well as what is the porosity, what is the chemical components present, the carbon components, humus, how much it is. These are different factors which can decides the basically how much will be the water holding capacity of the soil. So how do you know whether water is there? Like for example, it is like this. In this case, as you see, if you this is called as PWP, wilting point. You will have a soil. If you take the soil and dry in the oven, say around 60 degree, it will show loss of weight. But in the same soil, that means there is moisture available. But will it support plant growth? May not be. If you put a plantlet in that, seedling in that, it won't grow. Why? Because the water is not bioavailable. It is there, but it is not bioavailable. So therefore, below that point, even the moisture is there, or let's say water is there, it is not available for the plant to grow. Likewise, if it is above the field capacity, it will run off. It will run off. It is not available again. So in between what is there is what is available, right? We should be able to ascertain that, so that we can maximize the usage of what is available. Not only amount, for how much duration, that is also equally important. So then you have got how to know when to irrigate. So different types of soils, and as per that there is standards or what is already some experiments people have done and reported. So if you have different soils, type of soils, let's say sand, 7% moisture, that means once it comes to 7% moisture, then you need to irrigate, right? And then you have got loamy sand, which is 12% moisture. Likewise, if you go which is sandy clay and silty clay, there you have got around 30%, 25 to 30%, and clay of course is 31%. So that means when I mean you can ask me, why is that, sir, when sand is 7% you need to irrigate, why is that clay having 30% need to irrigate? That means clay doesn't release the water easily. It holds more, it doesn't give. Therefore, what you give only the plant will get, not more than that. That is why every soil texture and the quality will decide when and how to apply the water. So to address this problem, we thought in nature you will see that there are a lot of adaptations. You know about the desert plant? You might have in a cactus you grow at home, right? What is the structure of that cactus? The upper part? Thick, not like leaf. They are almost 1.5 centimeter thick, like fleshy. Why? Because they store the water in that, and then only when the plant requires it they give slowly. So therefore they can grow in the less or kind of water starved condition. So same way we thought of making some matrix which will be mixed in the soil, won't damage anything, at the same time hold the water, and whenever the plant requires it should be able to give in the root, right? So you understand the mechanism, how it operates in natural condition. Simulate something similar and give something which is compatible for the plant as well as for the soil and other microbiota. So in this case, as you can see, we have made a formulation using, it is acrylate based polymer, as we have introduced some biopolymer in it, and when you have a mixture, it is basically viscous solution. You introduce expose it to the gamma radiation, it will become cake. This is the reactor in which you mix it under controlled conditions, take out the liquid, expose it, you will get bulk gel material like this. And once you get this, this has to be cut into pieces and that dried and pulverized. This is done in a very normal, like 60 to 70 degree you can dry, don't need to dry very high temperature, and you will get a powder like this. Typically the size is something as mentioned 500 micron to 1 millimeter, 0.5 mm to 1 mm. So that is the kind of grain size you will see. So when you get this gel powder, what does it do? What are the features? If you look at, so BARCHydrogel, it can absorb basically 550 times water. That means if I take 1 gram of gel, it will almost take half a liter water. It can make a gel. So if you take a half liter bottle, take 1 gram, mix it, in 10 minutes you will get the gel. That is the gel you will get. We will have the demo just after this. So therefore when you are mixing with the soil as a uniform matrix, you can take various percent depending on the need. Every soil will have its own value to be optimized, but it varies from say 0.1 to 0.2% and goes up till 1%, even 5% depending on what is the nature or the water holding capacity of the soil. So therefore it can augment the water and nutrient retention in the soil. So therefore it can, yes.
How is this in comparison with clay?
Yeah, clay won't be having that kind of capacity. I will come back to that. Yeah, clay won't be having that much of capacity, as I said. Like for example, the clay that we used is, for example, making pot. We use the clay. That clay is something totally. It can hold the water, but as I said again, it is important in this case that we should know. You will have probably gel being sold in the market, gel ball. You put in the very colorful gel, put in the water, what do? They swell, nice looking. Do they release water? No. What does your plant need? It needs water, not capture as well as release, reversible. So therefore, clay, as I said in the last slide, clay can hold 30% water, root is not available. In this case it is not so. If you redry the soil containing the hydrogel, it will come to the original 1 gram out of the 500 gram. So basically it is completely reversible, releasing everything it has. So that is the essential part of making you have it as well as you don't have it. That's how nicely it plays a role. Okay. So therefore that it is slow and sustainable, as I said. It improves moisture content and hydrophysical properties, because when the water activity is there, nearby areas, all the microbes they want to grow, they also need water in the root zone. They also release nutrients for the plant to grow. So they also happily grow. This actually promotes the plant growth. Then reduce irrigation frequency. Of course, it will happen because of this effect of water being there near around the root zone. Then it enhances plant productivity. We will see the slide. Protects the environment against drought. So what happens is that suddenly, let's say the rain has just vanished in the month of September. Crop is to be matured in November. What to do? But you have only irrigation water available only for, let's say, 3 or 4 times, which is not good enough. In that case, we can apply this. Whatever water is there, we can try to save the crop. Like that you can adopt. Then protects the environment against drought and acts as insulating material for plant roots in frosty winter conditions. The reason being, when the water is available, it is capturing. So the rest of the zone near around it doesn't have that much water. So that frosty root destruction, this thing will be not there. No impurities due to cold energy based synthesis. So therefore, in this case, as I said, there are many processes. It could be chemically cross-linked, In this case it is physically cross-linked using gamma. So we are not using any chemical reagent for the cross-linking purpose, which are normally kind say not very eco-friendly. Then biodegradable and non-toxic. So one is to see that just like as you know people apply or the farmers apply compound every year or the organic manure every year in the field, still the nature of the field soil doesn't change much. Likewise your gel application in the field or in the soil should not alter the nature of the soil. If that changes permanently, then you have damaged the soil, which is not actually good. So therefore biodegradability and non-toxicity is very much important. So how it happens? This is the product that we pack. You normally pack it in a very nice pouch, which actually should be sealed, zip pouch. So when you require, you take it out, use it, again zip it. Because since it is taking water, it is hygroscopic. So when it is hygroscopic, that means you should be avoiding the moisture contact. Therefore, you look at this, you can, I will show you the powder that I have got. When you take little bit of powder and put water, it can swell like this, 550 times of its own size. So that's how it can. So then, once we got the product, we tried testing it in the room, in the lab conditions, whether it actually supports plant germination, growth, everything. So we have got rice as well as dicot plant, that is gram. Both were, just nothing, no soil, nothing. Because then you know what is the exact effect of the gel alone. Because even you know that at home we sprout the mung, right? We eat as in healthy food. So likewise, do you use soil? No. That's it. We soak it, overnight it will start germinating. In this case, we just made a gel, mix the gel with water, on that only we grew the plant. There is no effect on the plant growth. So therefore, we got the confidence that we can go ahead with the application. We did many other experiments, I am not showing that here, but this is one of the field experiments that we did in-house. You all can see the lady's finger grown in the field. You can tell me what is treated and non-treated. You can see the growth. So left panel shows that this is actually treated, it is not treated. In this case, see the size of the lady's finger. Typically what you see is around 7 to 8 centimeter. What we get in the market. But this one grew up to almost 8 to 10 centimeter. So a good produce on the same plant, same seed, on the next plot, just 1 meter away. Just 1 meter away. So this is the kind of result we got. And then we tested in various crops. Yes?
Are there any other features which are different apart from the length, like texture or?
No. Yeah, I'll come to that. The texture-wise, there is no change except that it improved the length and size. We didn't find any change. In fact, we had given it to this thing for for testing, for kind of distributed to some people also there, so that they can tell us without letting. We will not tell which is what. We'll just blindly give the sample, mix it and give it, and let them give the feedback. But we have not got any difference in that.
So no taste difference also?
No,
like,
no. As you can see here, this is flower crop. Yeah.
It actually acquires more nutrients when you
Yeah, I'll tell you. I'll just give you one example. You take this glucose powder, no? Right? When you are running fast, you want immediate. Okay? You are just running, also passing by. What do they give? If you are given a glass of water with glucose or dry powder, which is good, you tell me? Which is good? Dry powder or glass of water containing glucose? But so what does it mean? It should be available, soluble, right? So nutrients in the soil are also soluble in water only. They are bound to the soil particles, but they get released only when it comes in contact with water. Otherwise they are not available. So therefore, reason why you don't see the plant growing that healthily in the arid climate or there is less moisture. Come the May, there is dry soil, the same plant will have stunted growth. Plant the same one will happily grow when the rain starts. Soil has not changed. What has changed? Only the moisture. You got it? So therefore, this is very important. The bioavailability is facilitated by presence of water. Of course, there are many other parameters, but water is the main component. So as you can see here, it not only promotes root growth, and thereby it gives more surface area for the plant to actually acquire water. Now, having done this, what we did is that if this is so useful, then we should definitely make a technology which is basically practicable, not for lab. We should reach to the mass. So therefore, we are given this challenge of making 1000 kilo, 1 ton of hydrogel, and this experiment we did whole throughout the lockdown. You cannot imagine how we have done that. So procuring chemicals, and for 1000 kg we need to have almost 2000 liter of solutions, because you remember you are drying, only then you are getting powder. Water loss is almost 40 to 50%, so half of it only will get powder. So what is the initial chemical? 2000 liter. So that's what we did. So this is what you can see, these are getting mixed, put in the drum, getting transported for irradiation to the irradiation plant. You get the gel bulk material after that, and then we start coating like this, put in the tray, put in the oven 60 degree for more than 24 hours. When it is constant weight, take it out, it is dried, pulverize it, make it powder, sieve it through, get uniform particle size, roughly 0.5 to 1 mm, pack it nicely, and that is it. That's your product. So this is what we got. After that, what you do? You have got the material. Then it is supposed to be used across the country in many places, many agroclimatic conditions, and in many crops, so that we know actually it can make a difference. Therefore, we supplied some hydrogel to Agriculture University Jodhpur. They use it for the growing mustard. This is mustard crop control, hydrogel treated. What are the difference? You can see that growth are almost similar. This can be little better, it looks little better, but they are quite similar. What the difference was, the treated one, it was not given, one water irrigation was decreased. We did not give that much irrigation as was given for the control. Despite that, we got the same amount of harvest, which is comparable. That means you did not compromise on the produce, but you can still save the water, which is precious. So that's what we showed in the field condition as well. And then there is this lemon cotton plant. As you know, we grow in this ornamental plant everywhere in the campus, you can see. We did this experiment in our field there in the garden. So here also we can see treated one, how it is showing, and control, you can see. Same plant grown in the same time, and still so much of difference after we apply the hydrogel. So it is not that this is only one plant showing, or it is just a, by fluke it is only increasing, not like that. It was used in different conditions, and for that matter we also went to, like Delhi. There is a place called as Asulabhatti, and in this is New Delhi South. As you know, Delhi has less rainfall compared to many parts of the country, and there also there is some sort of water shortage. So use that area, and this is the plan of experiments which was done. As you can see, there are different plots, your treatment plots. As you can see, treatment 1, 2, 3, 4, 5. You can see 5, there is only hydrogel, no manure. The other one is manure. The waste treated soil that you are getting is the manure component. So if you go to the treatment 5, you can see only 36 gram gel is there, but there is no manure given. And the one that is T1 is having nothing, no gel, no manure, just the soil. Now we will look at how it is, how the plants are growing, T1 and T5. You just see, P is for people, T5 is treatment 5, that is 36 gram gel only. P stands for people, and for neem, we are given 2 plants, 2 different species to grow. So as you can see, same person is standing below the hand height. Same person goes on the other side, stands, T5, treated. Even if stands like this, height is beyond his reach. That is the growth induction happened because of the good, nice comfort environment created in the soil because of the hydrogel. And this is absolutely contrasting, and by the way, this is a result of only 1 year, I can tell you that. So this is our all directors, previous directors. This is Dr. Venugopalan, this is Dr. Ghosh, and our Sri Krishna Gupta, who is the DE official who were there, who were monitoring, because he was the nodal person in the Delhi office. Sri Krishna Gupta ji, who actually was present. So likewise we made several applications. This is one of the experiment, trial we did in the campus itself. This is our chairman sir, Vyas Sahab, who is doing the plantation. And then here is BK Jain Sahab and then director BRC here. So all people who have, if you happen to visit the campus, you will see next to NBH, the guest hostel, there are these plants growing with hydrogel, without hydrogel. You can have the picture as well. I'll show you, I have not got the photograph. The one which was treated with hydrogel started blooming flowers 2 months back. The one having no hydrogel is still waiting. So this is the difference. That means because of the nice environment it gives in the soil, it accelerates plant growth. So the cycle that happens, let's say flowering is to happen in 3 months, it can happen in 2 months. That's advancing the life cycle of the plant. What is the benefit? You reduce the water requirement. How? Because the crop will not be there. Crop was supposed to mature in 6 months, it will mature in 4 months. Have you not saved water? Not only you applied less water, but you also saved reducing cycle of irrigation. So there are multiple benefits. Likewise, you can see this is one of the examples that is there. If you look at these two plots, what comes to your mind? This is high density medicinal urban forest, a garden created next to the gate of entry in Anusaptinagar called as Miyawaki. So this has got 3.5 plants per square meter. Yani in 10 square feet place, like 2 tiles you can say almost, 2 by 2 tiles, you will have 3.45 plants. That is the density. For such, what happens? Why I am emphasizing this? More the density, more the water required. It's like in the same house there are 3 people and same house there are 10 people. Where will be the water required more? Where there are 10. Likewise, so in the same space, now that many plants are occupying. They need more water. Who will give? Does the soil have capacity to support? No. What do you need? Extra supply. How do you go? Morning once, evening once. Can you afford? Sorry. What to do? Look for alternatives. Of course, we can use this as a supplementation to support such. You don't need to visit every day, water it, electricity, manpower, attention, everything, saving, you name it. So that's how, why I am saying is just to make you feel why I coined it as water economy. Okay? So this is what. So you can see the dense forest, and as you see, December 2020, just July 2021. What is the month? 7 months, 8 months max. This is the kind of growth you can see. If you happen to visit, I can show you. And the last one is plantation work we have taken off in Vindhyachal range in Statue of Unity, Gujarat, next to Narmada Dam. The hill, both sides, one is Vindhyachal Parvat, the other is Satpura. In that you will see, if you happen to go there, it's totally barren. Many part of the stretch of that hill is totally bald, nothing grows. So it doesn't look nice. Next is statue on the right side with a nice flowing river and Narmada river, you enjoy it, there is a joy ride. But then next left to it is just like it is a desert. You don't feel good, isn't it? So what is the way out? They wanted to grow the plant there, plantation crops, which are like flowering plants, which will look good. But then it's not supporting. What to do? It is degraded weathered rock which has become sand particles. It doesn't hold water, it doesn't hold nutrient, very difficult to grow, sustain the plant. Normal tree plantation program that forest department is carrying out, they are unable to sustain the growth. Even saplings which are put also are not growing. So therefore we collaborated with them, and now we are in this task of basically making some sort of study where we have taken 1 hectare of land on the mountain hill, top of the hill almost, wherein we have 1,000 pits, 3 different type of saplings, flowering plants, natural to that, as well as some are which are typically used, and we are trying to grow the plants there. So we have just planted them in this July. Probably the result will come in another 6 months time. So this is what, as you can see, how does the soil look like? You can imagine where I am standing here with the team that we are doing the experiment. So this is the technology we developed, and it is AB51. NABTD is the technology code. Actually, the price is 1.8 lakh, but because of this time that we are having, like Azadi Ka Amrit Mahotsav, it is 45,000 plus the tax. If any company takes over this product processing part as a technologist, they can make an agreement, and then they can apply for the basically through the BRC sites and buy this technology. This will be only a technology transfer. So likewise, we have Plantation Energy Experts Private Limited, who was the first one to buy, who has now started mass production. Product is available in the market now, just to have got the first batch of product, and it will be basically distributed now. And then the second company is Well Dynamics from Indore. Third one we have already transferred Anand Sparks Technology Surat. Two more are going to be transferred one day after tomorrow, that is on 26th. So that basically within 8 months of technology launching, we have already got almost 5 people who are trying to reach to us and utilize it for the benefit of the common man. How it can be utilized for saving water and improving the agriculture. So here I would like to acknowledge the continuous support and motivation provided by Bhainsa, Dr. K.N. Bess, the chairman of our Atomic Energy Commission and Secretary DAE. Dr. A.K. Mohanty, our director of Atomic Research Center, who has been always monitoring and looking after this program, how to nurture, how to reach to bigger masses, how it can be made more popular, and how we can reach even the places where not many would like to reach there, because many places there is water scarcity, there are desert places like, western part of the country, as you know. So we are still trying to reach such places. Our director, Bioscience Group, Dr. Tapan Ghanti, who is basically in a part of the technology development, he was involved. He is one of the first person who actually drove the program through. Then we have got Dr. Prasun Mukherjee, who is my head, who is actually looking after day-to-day program of making it happen on the scale. And then my sectional colleagues were involved in development of this hydrogel, Dr. Mr. Devarna Datta and Archana Sharma. And these two are the people who are behind this, some of the work that we have done. And of course, we are collaborating with many people, as you can see here. Director, Knowledge Management Group, because they are the one who are disseminating the technology among the entrepreneurs. They are the nodal agencies. We are the developer. But you don't go to the agencies to say, this is the technology, please take it. They are the nodal agencies. Then we have a director, ESG and LNCM section, landscape management section, wherein they are the one who is basically, who are using it. The Croton experiment, the lady's finger experiment, we did with them, with their help only. Then we have got director DCSM, who is popularizing everywhere. We have got in this World Environment Day, we did launch a program of plantation in the mountain range in Anusudinavar itself using 25 kilo hydrogel. So they are doing it pretty well. They are basically popularizing in many places. Then you have got State Agriculture University, in this case Jodhpur, we have done the experiments. And of course there are many other universities which are we have already given, but report is yet to come. And of course thanks to all the technology entrepreneurs who are coming forward to adopt the technology so that it reaches to the mass. That is how we will have to reach further, and all of us are part of it. I will say you are part of it, because no one is beyond water. We are all within that. Thank you very much.
Thank you for this wonderful talk and demonstrating the technology of societal relevance. I think you want to demonstrate it here.
I will.
So it will be done.
So this is the powder that I can show you. I mean, if you want to see in the hand also, I can give you. Only thing is that this powder is, as I said, it is zip pouch. I can open it, as well as I can then, anyway, I will come down. So this is pretty harmless. we have made it, of course you can't eat, but then but you can definitely handle safely. Even gloves are not required. At the most what you need, just to make safe, because as you know, if this is powder, just imagine when you apply powder at face, what do? It goes inside eyes, ears, next to your sensitive organ. What do? Try to close. But while opening this, handling this, how will you close? You have to open your eyes to use it. So better to wear spectacles, or then you have also, you can wear the mask so that you do not inhale. There are very small particle size can inhale. The reason being, if you are inhaling, it's sticky, it will moisture is there inside the nostril, it will stick there. eyes it will stick. So that is the only thing to avoid, not to open very close to your face. That's it. Beyond that nothing will happen, nothing. So you can just take this, let's say this is the water. I will transfer now. As you know, this doesn't have anything, na? So this is just water. I will take, let's say, half glass. Okay. Now, of course, depending on the water quality, I don't know, like this quality, whatever it is. So I will put a pinch of it, not much, and then I will leave it for some time. And you can see. Can you just throw it and give me this again? So what happens, I will tell you. You can see, I mean, for benefit, if you want to see very first aggregation, I mean gelation.
Some water.
No issues. That's okay. Yeah. So what happens is that I just mix it. You can use a spoon or just stir it with anything, stick or whatever. It will start becoming gel. I can hand over you in just 2 minutes. Have it. Okay. So this is how it works. It will start becoming gel in no time. Very quick. Okay. So this, have it, sir. So this is how it is. This is quick, no problem, very safe. Okay. And you can really, this is what we aspire to do. It's not magic, it is real. You can do yourself if you want to come and try. So
Is it biodegradable?
completely biodegradable,
And what is the
safe also.
and what is the
Yeah. Yes, please.
what is the time period of the degradation?
Okay, so basically when we say typically the time period should be roughly around 180 days, which is considered as a safe, biodegradable and safe in terms of the environmental standard. Now some of the gels what is available in the market, they claim it will degrade in 3 years. If you look at go to Amazon, you will see one brand, I will not name it, but many people claim, somebody says it was for 2 years, somebody says it was for 1 year. We are not saying that, we are only saying this is a cycle. Why I am saying it, this is a cycle. Let's say this gel, you will say, sir, you have just shown us gel, you dry it, put it in the oven, it will become again powder, right? Same gel, put again water, again it will take. How many times such times you can do? 7 to 8 times. After that, it will start reducing the water holding capacity because it is degenerated. So same thing happens in the soil, and due to microbial activity, and as I said, why we are making this? Because we have put a biopolymer. So because of that, it is very easy to degrade. Otherwise, many of the plastics that you see, they claim it as biodegradable. They are not actually. You will get microfiber. Unlike this, which will be degrading completely. So this is not a plastic product. It is certainly acrylic based, but we have introduced many changes to make it totally safe for both soil application as well as even plugging wherever you want, like you can use it. In fact, we are using in some other cases as well where there is extensive water requirement. I mean, I can say that I don't know how many of you are aware. Do you see the same kind of stinking smell next to the market in the month of May or April? You go to vegetable market. Do you have the stinking smell? How much do you have during rainy season? Much more. Why? Moisture. What does it mean? Higher the degradation, more the moisture, higher the rate of degradation. Where can it be applicable? In your own garden. Every day your gardener collects truckload of leaves, dry leaves. What do you put? What do you put? Either you burn it or send it for composting. How much time it takes? 2 months minimum. If it is coconut leaf, 6 months, right? How to improve the degradation? Dry leaf. Same thing. You take cabbage, no? Remaining part of cabbage you keep at home. Next day it will stink. Why? Lot of moisture. That means moisture is a very important part for accelerated degradation, which means that you can use this for accelerated degradation of leaf, dry leaf, especially in the dry period. We have already combined this with one of our technology, which is rapid decomposition technology, available in our division with one of my colleagues using trichoderma fungus. So now that technology is coming up. We are going to give a certain formulation ratio, how much leaf, how much gel, how much of decomposition trichoderma product, so that you can degrade it even in the peak of summer very quickly, let's say 25-30 days, 20 days, so that the pile of stock of the waste is not there. So there are many applications. This is just example I am telling. Similarly, there are others also, but I mean environmentally and ecologically and agronomically what is possible, how we are supporting that same leaf product becomes a compost product for the agriculture. So we are looking at that way. Yes.
Yeah. What happens if someone swallows it accidentally?
As such it is not very harmful, but it depends on the amount. No, it will go egestion. There is nothing called as digestion and absorption like that. It will not happen, but it is best avoidable.
Yeah.
Not edible. It is not edible. It cannot be recommended for any. It best avoidable, I will say.
Yeah,
So you should be keeping out of reach of the children, I will say.
uh,
Yeah, because same way, I will just one example I will give. For example, you see, many of us comes from farmer's family. In house you have got urea, right? Almost all family will have during kind of when you are sowing the seeds or growing. What do you keep like that? So please keep it at a safe place, cool, dry. Not cool. Cool is not a problem. Keep it at 50 degree, no problem. In fact, the best part is it can take water from 5 to 50 degree. Remember that. If it is cold, there can be dry cold also, right? Even then it can take water, correct? Okay? Yeah. So,
Sir,
please.
I had two questions. So
Please.
my first question is, can it absorb humidity? So in place like
yeah, you
Chennai,
certainly, but it is nothing but another form of water, no?
Yes.
It's a moisture water, right?
Yeah.
So therefore, if you have the gel, dry gel, I keep open this packet, it will start clumping.
Okay.
That's why I am saying it is zip pouch. I have zipped it already after removing.
Yes, yes.
If it is not zipped properly, in my hand it is there, no? It will stick to my hair. You see? It's just talk. You see? Just talk.
yes, yes.
Okay.
It will. It will. So it's best that you, when you use it, open it for that much time that you want to use, and just seal it. That's it.
Okay.
But temperature is no issue.
Okay.
Moisture is issue. Yes.
My second question is, if we take this gel and we squeeze it, do we get the water back, or does it only release it slowly?
That's the. It's like banana, you know. Squeeze the banana. Will you get the water? No.
Okay, okay.
It's just like that. Very difficult. You won't get it. Only good thing is plant is very adapted. It can still suck the water from the gel. That is the best part. Why you tell? Because osmotic. That's correct. So therefore you won't be able to drink, but plant can, no problem. Yes.
I know there are many more questions, but there is also a plantation thing which we have to do, and we have another talk in an hour. So since Dr. Kuber is around, I suggest that we interrupt, but before that we request our director and registrar to felicitate Dr. Kuber for the
Thank you. Thank you very much.